Welcome to the Fast Modes podcast series. I'm Tara, and with me today is Chris Gu, Principal Product Manager at Spirent Communications. Spirent is a leading global provider of automated test and assurance solutions for networks, cybersecurity, and positioning. Chris joins us today as part of our exclusive editorial segment on Open RAN. With a robust background in cloud-native 5G technologies and Open RAN, Chris excels in driving product development, business and technology strategy, and team leadership. Previously, Chris held significant roles at Dish Networks, including Principal Engineer Architect and Director, Head of CI/CD and Automation. During his tenure, he spearheaded initiatives for Open RAN zero-touch provisioning solutions, significantly reducing costs and enhancing the efficiency of network deployments and operations. Great to have you on the show, Chris.
Thank you, Tara. It's nice meeting you.
Yeah, nice meeting you too. Okay, to start, can you give us an overview of the concept of Open RAN split and why balancing centralization with disaggregation is important?
Open RAN is a very important step towards 6G in the future, right? So it's not just simply for one particular applications. So it's more focusing to the future development of this Open RAN. The RAN itself, in the past has been centralized, as we all know. The big issue is the scalability. And Open RAN is trying to introduce this scalability by disaggregate the network components. So Open RAN Alliance developed these, the standard specifications, basically separate the ORU, DU, and the CU, so that the interface between all these can be open, so that more vendors can get involved, and also so that give the flexibility of deploying. So create a so-called centralized deployment and a disaggregated or distributed deployment models. So that's why Open RAN is so fascinating. This is going to dramatically change the industry through time, so that when the entire network moving toward the future, so we can scale up the network more cost effectively.
Great. So what are some of the main deployment topologies you are seeing in real-world Open RAN implementations? Like what are the considerations that influence whether operators should choose a centralized or disaggregated Open RAN deployment model?
Yeah, this is a very good question. So when we say deploy the Open RAN in a centralized or disaggregated manner, really depends on the business model, right? So from operator point of view, they're going to see not just one kind of deployment. They're going to see multiple kind of deployment. So when I say multiple, because it really depends on the cell coverage and how they deal with the traffic density, right? So when we consider about the macro cell site deployment, normally macro cell site has a large coverage. So in that case, you want to deploy the DU/CU as the traditional way in the cell site. So then, so when we do the engineering, you can follow the traditional staging process without challenges on logistical part. But there is a limit on this one. So when you deploy on these microcell sites, especially on the dense urban area, on the street, in a dense populated area, macro cell sites may not be a good choice, because in that case, too much traffic concentrated on one particular cell site. So instead, you want to deploy multiple smaller coverage cell sites, micro cell or smaller cell on the street. In that case, how to handle that cell site traffic across the small cells becomes a challenging part. So in that case, you want to use the disaggregated or centralized way to deploy, which means you put the DU in a particular location, have a specific geographical coverage, like a block of street. You have multiple cell sites, connect them. Only you deploy the RU on each cell site. In that way, now you can concentrate the traffic on a particular region. Meantime, you reduce the handover overhead. You concentrate the traffic into the DU. So then you have CU further deploy out in the like a central office area, cover like a square kilometers or square miles instead. In that way, you can have lots of cells interconnect to this concentrate to the same CU, so you can have the efficiency on the CU side. So overall, in this case, you can see is how to plan out the traffic coverage, and also how to utilize the hardware more effectively, which here the hardware means the computing resources on the DU and the CU side, and the transport resources. You want to use in a centralized location to improve the efficiency. So there's a trade-off between the disaggregated deployment and the centralized deployment, because in this case, when you do the centralized but a disaggregated DU and CUs, you get more involved on the logistical part in terms of transport, in terms of where you're going to deploy the DUs, and all these, how you're going to handle logistically to make sure the security, the hardware delivery process all match with. This is a little more complicated, but it delivers more value from traffic point of view, from network efficient point of view. So there is a subtle different balance between the centralized and the distributed or decentralized deployment based on business model.
Brilliant. That's really a very in-depth explanation. In your experience, how do different RAN splits impact network performance and also end user experience?
Yeah, this pretty much we can say from multiple point of view. You look at this network deployment today, right? So depending on the application again, for 5G, for example, we focus on three things. One thing is the real mobile broadband applications. Another part is on the IoT, on the massive number of sensors, how you connected, right? So number of connections is more important. The third one is low latency. So using for manufacturing, robotics, all these parts, you want to minimize the round trip delay for the control messages. So it depends on the business model again. So now you have to make a trade-off. So for example, if you deploy the cell site for mobile broadband, in this case, now you need to pay attention not only just the broadband on the radio itself, right? The RU, say, using spectrum to cover the broadband, like a 100 megahertz channel, or 80 megahertz channel, depends on the availability. So you really want to maximize the bandwidth over there as much as you can. Meantime, you have to make sure you have enough transport capacity to deliver the traffic. If you do the distributed or decentralized deployment, which means the CU and DU in different locations. So now transport bandwidth becomes issue, right? Because concern. And since let's say DU concentrate multiple cell sites, now DU has to handle a lot of traffic. The power or bandwidth of the DU becomes also subject. Say, how can I handle the mobile broadband? Do I have enough bandwidth? Do I have enough CPU power or hardware power to process all these broadband bits from different devices concentrated to this particular DU? And then further up to the CU portion, now you have more cell sites, more DU traffic holding into the CU site or data center. Do you have enough bandwidth? So you can see the further up towards the CU, the further bandwidth is required, further hardware resource required. So all these software quality becomes a concern. How to handle, multiple sessions, the multiple, users, how to manage them in terms of the quality. So different level of concerns has to be addressed at the CU, DU, and RU level. So in short, for broadband, you need to drop focusing on how to deliver the broadband experience. On the other hand, when you deliver the ultra low latency applications, as I mentioned, the other deployment scenarios, in that case, you really want to conserve DU where we're going to deploy DU and CU, because if it's too far away, you may introduce too much delay there, the latency there. Now, and also on the user plane, you may want to push the UPF from the core side closer to the CU as well. So then you can reduce the overall round trip delay. In this case, the performance concern on the transport and the processing latency becomes a big thing. So people need to pay attention on that deployment scenario. On the other hand, for IoT, bandwidth is not a big concern. Latency may not be a big concern, but number of sessions become the concern. How many sessions or maximum number of sessions you can handle concurrently through the same DU, same CU becomes a very important parameter or KPI to check it out. So overall, depends on the deployment scenario, depends on the applications. You want to balance not only just the topology part, and also you want to check define the key parameters or indicators, KPIs, against different units like the RU, the DU, and the CU, and also make sure the bandwidth has to be managed, measured, indicated by the KPI as well. So then you can monitor all the qualities of different elements to make sure you meet expectations of applications.
Well, that's insightful, especially, how we explained about how applications determine how you design the RAN split. Now, how does network security impact open RAN deployments? What constraints does it introduce when choosing the right RAN split?
Oh, this is even more challenging question. Yeah, yes. From security point of view, right? So of course, for centralized one, traditional way, if you deploy everything into one location or one box, for example, DU, CU, and RU, in the traditional way, you put the so-called distributed RAN, you have DU and C combined in the BBU. Now everything, especially in closed case, you don't have other vendor get involved, and then it becomes the only open interface towards the outside as the backhaul. Then as long as you secure there, you feel much comfortable, right? But if through this open RAN, now you have disaggregated architecture and allow other vendors get involved. So which means the RU, DU, and CU becomes trustable each other. How do you secure them? That's become number one question. And then for interface, all these interface from transmission point of view, how do you secure them? That's another dimension of questions, right? So, and then going back to the central management point of view, when you do the software upgrades, how do you manage the security? So this really depends on the deployment topology again between the decentralized and the centralized deployment. You have to consider in layer structures probably. Why I'm saying so, because if you think about it, the traditional RAN deployment, we normally call it node-based. Since all these hardware comes out of the same vendor, now you have one box or one node deploy that way. So as long as you measured and tested and secured that portion, then you can deliver the device from the warehouse to the sales site, and without any issue, right? You keep tracking in the middle, of course. So from logistic process, it's relatively simple. You do the centralized staging process and checking everything there. But now, since you're doing a distributed way or decentralized deployment, what happens is, especially if you are using cloud-based or virtualized solution using generic computer, BMC, bare computer, a bare metal computer instead of the dedicated hardware. Now you have to think about how to secure from low level, from hardware BIOS point of view, and from operating system point of view, from virtual machine point of view. On top of virtual machine, now you talk about container, from container point of view. When you touch all these, now you talk about cluster deployment rather than single node deployment. When I say cluster, what does it mean? Means, so for example, for BIOS deployment on a computer, now if you're doing single computer, everyone is checking for different computers on the BIOS and then stack up. Now too many things to handle. What you do is normally you do make a management system available to manage all the computer within underneath of the same CU, for example, or same DU as a cluster. You can say, how can I upgrade these BIOS together to make the security updates compatible each other, rather than when the different DUs talk to the same CU, and then you have this I would say the security clearance point of view may not be strict enough, right? If, for example, somebody using different versions of the software, you may not know. So now if you're using cluster deployment view, you have to check adjacent cell size, adjacent DUs, all using the same versions of software. So what I'm saying is we have to think about how to secure things from layer structure in the cluster scope under the same CU, rather than using the traditional way of node-based security checking. When we do that, now you can do not only just the transport, physical layer security. You want to check the BIOS, you want to check the OS, you want to, which through the patching, all this OS has to be secure up to date, and you want to make sure the VMs on the top is patched properly, keep it secure. And then on this top of the VMs, now we talk about the containers, how to using Kubernetes to make sure all this secured, operations secured, right? Then when you load all this, deploy this DU, CU software on the top, you have to make sure from the SMO down to the each DU and CU level, the transmission delivery of the software and operation of software, all channels are secured. So this is a very complicated and a complex process, but definitely it's critical, have to be thoroughly designed and think through before you really put the system into the field. From that point of view, yeah, the lab testing validation becomes extremely important.
Yeah, I can see, how complex this can become without the maybe visibility into the end-to-end, network. And also, when we are trying to balance a lot of outcomes at the same time, we have performance and end-user experience, and then we also have security, and then we have different applications that we have to cater for. So really, it becomes complex and it also becomes interesting. So yeah, you just mentioned that. What is the role of real-time end-to-end testing in both aggregated and centralized Open RAN? And more pertinent to Spirent, how do Spirent solutions address performance testing needs in all these different scenarios?
Yeah, I think so. We from this overview, you can see number one, we probably don't even mention too much the testing of the end-to-end. It's very important to make sure so we know what do we get in the field before we deliver to the field, right? You don't want to surprise that one. So when we say end-to-end, really say from end user point of view, if I started launching a YouTube, just simply watching the YouTube, do I have enough bandwidth? Does the system provide enough bandwidth and manage it across different elements? So using real application to test end-to-end to experience the user experience, it's a very important. So from that point of view, you step back and then say, okay, in order to secure my user experience, how about others in the middle? If those elements behave as I expected, not only just to collect the KPIs, right? And also, do you have enough data at a different level of protocols? Later, if anything goes wrong, I can help. All these log data can help to analyze, to help troubleshooting, to figure out what's going wrong. And then when you do the end-to-end, the next level automatically going down and say, okay, now end-to-end is not going as I expected. How can I isolate them? Then you do need adjacent node testing, right? You say, oh, okay, my entire ORAN is not behaving as I expected from end-to-end point of view. Is that because of the core or because of the RAN itself? Now you need to test the, all we call the wraparound testing, see the end-to-end of the RAN itself, and using the core emulation to drive the RAM to see if the RAM behaves as we expected. So in that way, you can gradually isolate things and going down and in sequence as well, right? Finish the RAM portion, say, yeah, RAM end-to-end looks fine. Now still the end-to-end is not good. Now you want to go down to next level. So for example, try to figure out is it CU issues or DU issues. That's what I'm saying is, although it looks like end-to-end, you really need node level testing and adjacent node testing, so that you can isolate things quickly. So to cover the whole things to help you to troubleshoot the network. And in this process, now you found, if you introduce different test equipment or test tools to focus on different things, now you found the things become very complicated because your network have to match the applications, have to watch with the deployment topologies that we mentioned earlier. Now you talk about decentralized and centralized, different topology combinations, different transport and configurations. All this becomes more complicated. So that means for your entire testing platform, it has to be highly scalable. Right, so you don't want to say I introduce multiple platforms, multiple tools, and then learning tools every day. You want to have a single platform so that you can test things in different ways by configuring tool in different ways. So single user experience now becomes important, right? So when you change the network configuration, change topology from test point of view, you want to make sure you can pick up things very quickly and touch and feel the same way. You don't want to say change the topology of the testing system on the test system on the test. Then you have to relearn the user experience, user interface, the graphical interface portion, or even process the data in different ways. So it's just too much learning and time spent in the lab. So the single user experience, single interface becomes important. Second part is, since the Open RAN gradually getting more and more virtualized, now you find that when you find the issues, you want to quickly patch it to fix it and see, then rerun the test. Can we validate, say, confirm, say we have fixed the problem, find the root cause to fix the problem, right? So this is another part of test complexity. This complexity can be handled through test automation. Instead of doing by human, every time you do the software change, you want to introduce CI/CD process and to leverage testing automation to implement the continuous testing or CT process. So now you combine CI/CD and CD together, so to address how to reduce the complexity from testing logistic point of view, from data analytic point of view, for cost efficiency. So this is the second part about. And the third part about testing, of course, you have to address the capability of the testing, right? So it has to offer all kinds of testing, not only just the conformance. You want to have compliance testing and automated testing and all different combinations. So that the different test cases can be combined in different ways. So you want to have the open API or RESTful API, so then you can call each test case through API and then combine them in different ways. So make this entire test system comprehensive and powerful. So for short, when you develop the test system to handle the complicated Open RAN testing to match with the topology and is decentralized or centralized different testing scenarios, deployment scenarios, addressing different applications, different use cases, you better have single platform, but this platform itself has to be highly flexible and configurable so that it can handle different things under the same umbrella to have the same user experience and fundamentally improve the cost efficiency and reduce the total cost of ownership.
Okay, wow, that's amazing. We can now see how, having a flexible solution that addresses this using a single platform would be really valuable for operators. and also other providers experimenting with Open RAN and also deploying it. So yeah, thanks Chris. Thanks for walking us through some of the very pertinent topics on Open RAN, particularly the many considerations we need to take into account in deciding on the optimal RAN split. Thank you again.
Thank you.
Okay, so and for everyone else tuning in, if you want to learn more, visit spirent.com and follow us at the Fast Mode for more updates and insights as we continue to uncover the latest in technology and telecommunications. See you in our next session.
Thank you, Tara.